It's a mad, 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 mad world. It's a movie. Check it out. Really funny. Now, in this problem, I want you to see that you can solve this by using the quadratic formula. In the other video, we saw that it would not factor, and we couldn't use the square root property, but we can use the quadratic formula. Now, do you guys remember the formula for the quadratic formula? Ready? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. See, just like that. There's your formula. What is your a?
3.
What is b?
Positive 12.
What's c?
Negative 30.
I'm going to show you that you can do this. This is not pretty, but it can be done. So that means that x equals negative b, which is negative 12, plus or minus the square root of b squared is what? 144. Now the minus 4ac means negative 4 times 3 times negative 30. What is all of that?
First of all, we know there's negative 360.
Positive 360, right?
Yeah.
Did anybody ever tell you that they had an addiction but they turned a complete 360? Yeah. It's not good. What's 2a?
That's 6.
It's 6, right? Do not reduce the 6 and the 12. What you need to understand is that 6 is the denominator, not just for the 12, but for this whole guy right here. So this is negative 12 plus or minus the square root of 144 plus 360.
504.
It's 504, and this is still over 6. I'm not done because I've got to break out whatever perfect squares are in 504. Off on this side, we're going to do a factor tree. We know that 2 goes into 504 252 times. 2 goes in here 126 times. 2 goes in here 63 times. I'm out of 2's. Now do what? 3 goes in 21 times, and 3 goes in 7 times. This is your prime factorization. Do you see the pairs that will give you perfect squares? This guy will give you a 2. Anything else?
3.
You have a pair of 3's. So what comes out of my square root? A 6. And what are the factors on the inside? What's left over?
14.
2 and 7 is 14. This is all over 6. Now I can reduce everybody by the common factor of 6, and I get what?
Negative 2 plus or minus the square root of 14.
Negative 2 plus or minus the square root of 14. Do I need to write a 1 in front of that?
No.
No. Is this the same answer that I got before?
Yeah. So hypothetically, the quadratic formula could be used every single time.
You can always use the quadratic formula on a quadratic equation. If it's x squared, x, then a constant, as long as the highest guy is x squared, you can always do that. But will it always be the most efficient way of doing it?
No. I'm just saying
No.
hypothetically, it could be used.
Right.